Hello, everyone, and welcome to another Meteorite or Meteor Rock ID with the Knowledge Bolide Crew. Before we get started, what do these numbers mean? Why are they important? Well, they're important to two of our crew members, to Cal and Maxime, who were just allowed into the International Meteorite Collectors Association, IMCA. So, congratulations, Cal and Maxime. We're very happy for you, and I see the crew is applauding. So, right now we're going to be looking at some rock IDs. This is number one. This is from Clark. It was found in Ontario, California, on an asphalt path. He says he walks this path often, and it wasn't there. Then it was there. So the rock weighs 158 grams. Oh yeah, Sue made these slides, so good job, Sue. Thank you. We actually have highlighted now what the submitter is telling us to look for in this sample, because these are things that they are thinking they're seeing. So be on the lookout for impact fractures, fracture lines, fusion crust, chondrules, flow lines, and a red tint. So could be interesting, guys. Love to have your opinion on this one.
Hello, everyone. My name is Clark, and I live in Canada, Ontario. And I would just like to show you a crazy rock I found with nice characteristics. Happens to weigh 158 grams. And it has all beautiful fusion crust, I am presuming. Happened to fall on an asphalt path that I travel many times a day. And it just happened to show up. After passing it for a day and a half, I decided to pick it up and investigate it. And it turns out that it was very magnetic. And I did do a ceramic scratch test that I hope a picture uploaded is even shiny particles all through it. Beautiful. And even better, a presumed impact fracture with fusion crust, fracture line, chondrules going right through, impact fracture goes right to the backside into some beautiful flow lines that do have a nice red tinge to them under the proper light. Another slight impact fracture. I just found it very interesting, and I'd like to know what you people think.
We actually got a really good look at this sample, guys. And we'll go to Allison first. Allison, what do you have for us?
I want to start first with just some flow lines. I want to address what we're referring to as flow lines in here. If you could put our camera up there, please. And I'm just going to address that and hopefully leave room for everyone else to talk. What direction are our flow lines going? Just asking.
All over.
Exactly, every direction imaginable. And flow lines in meteorites would be oriented and would also express an oriented flight on the stone. And we can't pick which end of this stone would have been the nose of the orientation and which end of this stone would have been the rear of this orientation on this flowy pattern here, because it's not going one direction or the other. It's sort of going every direction and kind of meets up in a crack, which doesn't really look meteoritic to me. It looks a little earthy to me. So I'm just going to pass the mic from there. That's just one thing I saw that stood out a lot to me.
Yeah, so this is an actual meteorite with flow lines. And let me see if we're gonna, as you can see, they're hard to see. They're always on the outside. And there
There
you
you
see,
go.
you can see them obviously rotating out from the center to the edge. Perfect. And then maybe even coming around the side. You can see a few too right there. But yeah, exactly what Allison was saying is that these are going in one direction, really going aligned and going in and showing direction of flight. So thank you very much, Allison.
Hmm.
Dave, what do you have for us?
Yes, yeah, I did see those jumbled flow lines, and yeah, I agree with her. That's totally correct. And my problem is those the pitting in the what was considered crust. When you showed the previous sample of a real meteorite, the crust looks completely different. It's not so much smoother, but it's lacking those pits that you never really see on a meteorite. And I didn't really see anything of the interior. It looks like the actual dark color is just goes through the whole thing, and that's would not be a meteorite. That could be slag. Now, I'm a very bad judge of slag, but that might be some sort of form of slag. And that's what I got.
Awesome. I appreciate it. I have 3 hands up. If someone with their
Topher,
hands up, yes.
since Dave brought up the fusion crust, why don't you jump to slide number 8?
So this is an example of actual fusion crust. And you're right, there's no holes, there's no pitting in it. Yeah, I think it's helpful to see a real one versus next to, as close as we can, next to a
I
potential.
agree. To piggyback on Dave, if that's a fracture, we would sure hope to see the inside of the rock not look exactly like the outside of the rock. And that would especially back up a fusion crust if that were a fracture, as our viewer has indicated. And it does look like a fracture to me. But again, if it was a meteorite, we would hope to see it look just like that Venalis or close to, different on the inside than on the outside.
Correct. Chris?
So I'm kind of at this point just going to double down on what Allison and what has been said so far. The first giveaway to me was the homogeneous texture and color. The vesicles form typically when you have a really hot liquid that cools very rapidly and the gas gets trapped and tries to escape. That typically doesn't form in meteorites unless it's a melt. When you have that, what does look to me like a fracture, I don't know about impact fracture, but definitely a fracture where a piece is chipped off, the inside color is almost identical to the outside color. You have the red, a little bit of a red tinge on that bottom area where it looks like lava rolled over some old lava and cooled, forming that texture. And anything rich in iron, when it oxidizes, is going to have like a reddish tinge to it. So yes, high iron content. Obviously the magnet sticks to it, but the homogeneous color kind of gives it away the most for me.
Thank you very much, Monk Man. Art Wagner, what you got going on in your brain, man?
Yes, sir. Well, first of all, I'd like to compliment the submitter on excellent photography there. I mean, everything is very sharp and clear. What I would like to agree with was Allison's comment about the flow lines going everywhere. Looking at that, it reminds me of liquid metal that was in a furnace, something that was incorporated probably to make steel stronger, some sort of process of that. And all of the vesicles in it, it just says slag to me. And of course, you know, a magnet will stick to slag. And as Chris Monk was saying, the reddish hue that is typical of iron, you know. So even though he said he performed a streak test and it left no mark, so I don't know what he used as a unglazed porcelain tile to conduct a streak test on, or he just went to the glaze side, which he's not going to get any streak from.
Yeah, thank you, Art. We're actually going to have a little bit of a video or a segment or just some education on streak tests, because I'm getting a lot of samples submitted to me, and the streak test is like not done properly, not done accurately, not shown off. So
It's very magnetic, yet we're not seeing any iron nickel blebs in there, or nor are we seeing an iron, nor are we seeing a palisite. So,
And no chondrules.
yes, agree.
Pat, cluster chondrule man, what's going on?
So yeah, this is not a meteorite. This is most probably slag with a slight chance of being Pahoehoa lava. So there's gas bubbles in here, and if we look at the gas bubbles carefully, some of them are not spherical. The ones that you find in meteorites will be spherical based on surface tension. If you look at the left, right kind of below his magnet, there's kind of an elongated triangular shape, a little lower right there. That is a expanding gas bubble that's been pulled into an elongated shape. So there's also, they're a little hard to see, but there are also conchoidal fractures on some of the other surfaces. Chris said uniform color inside and out. I don't see any chondrules. There, he also mentions iridescence, which is a diagnostic for slag as well. And if we go back to that area that he's calling, okay, there on the left, you can see a conchoidal fracture and then one in the center of that face. They're a little hard to see, but that's what they are. And then if we go back to the wrinkly,
this area right here and this right here.
Yes.
Okay, thank you.
And if we go to the wrinkly skin that he's calling flow lines, that is a classic feature with slag. It skins over and then it continues to move in a blobby plastic sort of flow, which pulls those lines in different directions. So this is almost certainly slag, slight chance of Pahoehoa lava, zero chance of being a meteorite. Thank you.
Awesome. Great job. I appreciate the indie speed at the end. Yeah. So really good information. I agree with everything the crew said, and there's nothing to add there. Let's go on to meteorite number 2. This is from Andres. Andres, I believe, sent in his first attempt. His video was very flattering, complimentary towards the crew. He enjoys what we do, was very nice about saying that he had some people he was really fond of on the crew watching and listening to. So we appreciate that. It didn't make it into the final edit because we're always looking to get a better video, and didn't have narration on the better video. So this was found in Louisville, Kentucky, or Lawville, Kentucky, in a backyard garden. I think a brick was knocked over and it was hard to remove from the ground. So I guess it was impacting at quite a speed. Weighs about 2 pounds. And everyone out there, don't call it slag. We don't think it is, but he says he doesn't believe it's slag. He suspects it to be the first North American lunar. So this is not the first time I've been told that someone's been approaching me with the first American lunar, and I want to be there with you guys. So and it does have varying magnetic pulls across different sample areas of the rock. These are some of the terminology, some of the identifiable features that Anders was able to pick out on his side. So we're gonna look for some of these again. Now, this, I don't know if he's saying this is a good thing or a bad thing, but vesicular fusion crust, we were just talking that it's not really a good thing, but it's seen once in a while. So I'm anxious to see this, guys.
Hey guys, I'm Andres Chavez and I live in Louisville, Kentucky. Found this in my backyard near my garden, little dirt area, and as you can see, it's got a little crust. I think it's fusion crust. All that right there is fusion crust. As you can see, it's a whole little layer. You know, it's completely different than what the interior is. It's got little regma clips here and there. See the little regma clips? There. You can see it sticks to a magnet. See the interior is a different color right there. Look at that, guys. Different color right there. So it's definitely some type of crust. And you see it's got clast here and there. So I'm thinking it's a lunar meteorite, maybe. I hope. There's little vesicles and stuff right here. So I'm thinking that's vesicular fusion crust. You see it right in there too. There's little vesicles in it. I'll send you guys some good pictures of it. And you can look at the crust right there. It's weird. See how it's sparkly? It's just different. And look at the regma clips up here. And I'll show you, it's not magnetic all the way. Let's see. It sticks in a lot of spots, but look right here. Right there, it just falls down, see? See? It don't stick right there. Hopefully you guys can let me know what it is, because I have no idea what it is, but it's a very interesting rock. And I'll show you that there's no mark on there's no mark on here. Let's see if I can find a good spot right there. See that there's no mark there. No mark at all. No. See? Thanks you guys for helping me identify this. And you guys do an awesome job, and I love y'all's videos. You guys are cool. I'm into rocks now since I found this, or in meteorites actually, and rocks. But let me know what you guys think it is. I honestly think it's lunar, but I don't know. I could be wrong. I just hope it's something. Let me know what you guys think, and thanks for watching my video and helping me identify this. Thanks, guys.
Good job. I appreciate that. We have some hands up. Let's go to, we know Allison's
Topher, we have photos first.
Oh, we have photos. Okay. Thank you, babes. Yeah. So if you see something that you were going to highlight, remember the picture and we'll bring it up for you.
And these little words here, these are all things that Andre had mentioned.
All right. I will be going to Dave Pinsky, then Allison. Dave, can I pull something up for you?
Number 2. Well, that's a good one. So he was talking about this all being fusion crust. First of all, it doesn't look like any kind of fusion crust that I've seen. It almost looks like some kind of chemical that's over the thing, or that's spilled around it. If there's fusion crust, it wouldn't be on the internal parts of the meteorite. And you can see all of that dark stuff is on the inside. It looks like that dark stuff just got poured on it or was dropped onto it. And when he was doing the street test, it was crumbling off. Fusion crust doesn't crumble off like that. In terms of what the rock is, I have no idea. But the fusion crust alone tells me it's, or what he thought is a fusion crust tells me it's not a meteorite.
Thank you, sir. I'm really glad you pointed out the fusion crust not being available on the interior of a rock. These are things that we kind of take for granted, but we also need to make sure that we explain to everyone who's looking at a potential meteorite is if you're looking at the fusion crust, it's obviously going to be on the outside, the exterior of the rock. And when you have a broken face like this with fusion crust down deeper, that's an oddity. That's something that stands out as really weird. When you see, I think Dave said it looked like possibly a chemical or some compound poured in here, and it does look like it leached into the cracks and crevices and low points of the rock. So that's my 2 cents, but I'm glad you pointed those out. Allison?
This specimen, to me, it resembles an industrial waste product. And I don't mean that in a bad way, because I think this industrial waste product was pretty enough to pick up. But to me, this reminds me of, and I'm sorry that I can't remember it's a welding, a very high heat welding byproduct that makes like a fusion crust on this stuff, or a glossy crust. And that's really what this specimen reminds me more of than lunar. Again, mine's not quite the same color as his, but I wonder if that's maybe what we're looking at, is some kind of an industrial product of some kind. And that's all I have. I hope that the crew will talk as to comparing it to lunar more, but I wanted to just compare that and say it grabs my attention as a waste product of some kind.
Allison, would that be something that, like, if a big, work truck was driving by, that would like fall into his yard? He has like bricks around his garden. And he said the thing like looked like it knocked over a brick and then was in the ground. So if anybody has any theories about that, that would be helpful.
I think that would certainly be plausible. I mean, as equally plausible as lunar landing in your yard.
I want to ask Art.
What he's calling fusion crust looks very glassy to me, and I'm thinking that this could have been a product that was used by an artisan, and the lighter colors inside was something added to the mix for a specific outcome, and that's what I'm noticing. And I agree also with Allison that it could be some type of industrial mix.
Thank you, man.
Yep.
I want to also point out, and this is a lucky screen grab here, you can see all these shiny points that he mentioned when he was, that is not those are usually flat sides, facet sides to small crystals. And that's usually not something that is normally associated with, oh, wow, look, a nice meteorite. Pat?
Almost certainly smelting slag. We have to remember there are many, many different kinds of slag. Many different metals are smelted: copper, aluminum, or not aluminum, that's a different process, iron, many other metals. What he's calling fusion crust is way too thick and way too glassy to actually be fusion crust. We see on the first surface at the beginning of this video, we see the wrinkly skin from the blobby plastic-like flow. I see in some spots iridescence, which is also diagnostic of slag. And the stuff that he's calling fusion crust is way too glassy. Topher, excellent point. Sparkly is never good. That's either reflecting off of the inside of bubbles, like I think in this case, or crystal faces. The uneven magnetic draw is very diagnostic of slag. And the fact that it leaves no trace on a streak test is insignificant here. Streak test is really mostly about ruling out hematite and magnetite. So this is virtually perfectly smelting slag. Thank you.
Thank you very much. I appreciate everyone's opinions. I will add to it, like when you look at this side of it right here and the previous submission, side by side, they look to be paired material. They look extremely similar. So familiarize yourself with this look. It looks like someone melted a purplish black trash bag onto a rock. When you see that purplish black garbage bag completely melted and covering a rock, that's not what a fusion crust is looking at.
The lighter color stuff inside does look kind of the right color for feldspathe, but we have to remember they dump smelting slag on the ground at the smelting facility. It's then scraped up with a loader and sold for fill dirt or railroad bed or whatever. So I think we could have some local rocks entrapped in the middle of the slag.
Yeah.
Anywhere there's a railroad, there is smelting slag.
It's everywhere on the planet where a human being has walked except Antarctica. And rocks fly for many, many different reasons, including flail mowers, chippers, etc. So a rock showing up today that wasn't there yesterday is not evidence of a meteorite fall. Sorry, Topher, go ahead.
Oh, that's quite all right. I like getting talked over. No, I'm joking. No, I'm glad you mentioned the color of the inside, because we've seen a good amount of submissions of slag and MeteorWRONG Meteorite on Facebook. Slag, it's very similar on the inside as the outside. There's no, but you look at this and you actually see brecciation, you see some class, you see some flow, you see different. This is not your typical slag. So I appreciate everyone's opinion on this one. I do want to talk about one thing that we now should all know a little bit more about, and that's XRF results. So this was actually submitted with the sample, which is interesting because I had to get educated so I could understand it. What we're looking at here is an XRF result for a machine that's not set up properly for meteoritic samples. This is all about heavy metals. Everything on here is a heavy metal, and like there's no potassium. Like I remember that was the big one to look for, but your sample does not have, because this meter is trying to say, I'm testing a hunk of metal. What kind of metals are in this? Well, it's not a hunk of metal. There's some metal in there, but it's not a solid hunk of metal. So this machine is kind of filling in the gaps of what it thinks is missing based on what it's testing. What actually comes back is the only thing it can read. But it's saying this sample is 3% gold. So forget about lunar. You have a gold mine, buddy. No. So this is an example of the XRF machine not being used accurately, and we can see with the results here. We do see nickel. There's 2% nickel, but do you see any an iron? 71% iron. I'll just go ahead and say this is going to be the most heavy metal lunar ever seen, because lunars are not known for metal. So if you have a sample that is over 70% metal, it's not from the moon. So, and I know that we're not deciphering everything on here because that's a whole nother show, as you guys know.
Topher, your video is frozen.
All right, I can't get to the next slide.
Okay, guys, I'm taking over for Topher, and we're moving on to Meteorite or MeteorWRONG number 3. And this one was submitted to us from Adam, and I believe he is currently present. So this one was found in northern Nevada, I believe, United States, obviously, Jungo Flats. The rock weighs about 12.7 pounds, and thank you to Adam. He actually did performed a streak test and tested the magnetic traction, and both of these tests can be seen very clearly and obviously on the screen. I know on some of the other videos we watch, sometimes the streak tests are done, but we can't really see what was done before it's pulled off camera. So thank you to Adam for doing that. And things to look out for, what Adam believes he is a small patch of fusion crust, some fractures, and the other things I mentioned.
So I found this stone or rock out at Jungo Flats, northern Nevada. I found meteors there before, so meteorites. So the question is there are meteorites there, but this one was a bit odd to me. It appears to have fusion crust right there, just a little bit right there. I've polished that side. It looks like it's got some kind of fractures. I can't remember what they're called. But here's the unpolished side, and we'll do a scratch test. It does leave a mark, so I'm thinking it fails. but it's still, to me, odd. Like I said, there's fusion crust, or what appears to be fusion crust. It is magnetic. And oops. It weighs 12.7 grams. So let's just do a slow rotation for everybody, just to help out. Again, it failed the scratch test. I don't see chondrules. The only thing is that little bit of fusion crust right there, which I don't know if it's fusion crust or not. It's got those fractures in it. I'm gonna try to show all sides. And I don't know if passing a scratch test or failing a scratch test is definitive, but it definitely failed the scratch test.
That might be our
So
first
I found this stone.
founder who actually shared results that may rule his rock out as a meteorite. So we appreciate that honesty. And this is how science works, you guys. There are going to be some pictures. So let me share the pictures. All right. I believe this, I think this is maybe where he saw the fusion crust. I think. There's another close up. This is the polished side, I believe. The unpolished side. All right. I see that Chris has raised his hand.
For me, this isn't, it has some signs that would definitely pique my interest. The outside seems like a very typical color of a chondrite. In the video, not so much in the picture, it does look a little bit like fusion crust on that one little patch. But to me, the inside texture looks more like dino bone or something like that. There's no obvious signs of chondrules. Now, in some achondrites like ErgCheck 002, it kind of has that spotty pattern. In ErgCheck, they're more elongated spots. But we have seen that pattern in meteorites before, but it's not very typical. So I'm leaning towards it's not a meteorite, but I definitely get why you picked it up.
Yeah, I mentioned that to Adam, that even if we kind of the crew discusses and we kind of agree that it's not, I'm like, I think most of the crew would have picked this up.
And just piggyback on Chris and say that I could absolutely 100% agree. It's got some good looking things, but it also has got some really like terrestrial looking things. But it also, I would have picked it up, and I'm super glad that as a crew we get to look at this rather than somebody sending this to me personally. Because if somebody would have sent this to me personally, I would have said, so, whoa, we need to ask the crew. So this is a good one.
Yeah, for sure. All right, Pat.
Yes, so this is a tough one. I think the things we can say is that there's no metal flecks or metal blebs anywhere, interior or exterior. The interior, and good job of cutting a face and giving it a polish so we can look at what it really looks like. It's extremely fine grained. So it's not an ordinary chondrite. I don't see any evidence of chondrules. If it were in fact a meteorite, then it might be an achondrite. But the fact that it has that much magnetic attraction is troubling. So I'm gonna fall on the side of I don't think it's a meteorite, but don't throw it out. I certainly understand why you picked it up. The streak test result that you got really looks a little like hematite. Now, I'm not a rockhound, so I have my expertise is the shallow end of the gene pool there, but I suspect this is some sort of hematite. That's what I had. Thank you, sir.
Art?
Very good photography and explanation. And I also can understand why you picked that up. And from what signs I'm seeing, I'm by no means an expert. I think it could be like a hematite nodule or something like that. But my hat's off to you. Very nice explanation and very nice photography. You gave us a lot of information, and quite frankly, out of all we viewed this evening, I would have to say this one is a stumper for sure. Thank you.
Yeah, I definitely agree. A lot of the rocks that we view, I think a lot of us can identify them right away, but this one definitely, Topher and I definitely stopped and took a second look at it for sure. Hey, Adam, are you still on, and would you be able to jump on and answer a question?
Yes, I'm here.
We were really impressed when you came to the hangout last week, and we had asked you about how you approached hunting, and we were pretty impressed. So would you be able to tell us about like where you went and how you determined that would be a good place to hunt, and like where you researched and things of that nature?
Well, about a year ago, I have a friend, he's still my friend, invited me to go meteorite hunting. And I was, just to repeat myself, who does that kind of stuff? So, but he was a friend I hadn't seen for a long time. I went and hung out with him. He showed me his metball and all the geolocation of the meteorites. So we went out to Jungo and search for meteorites. We use magnet sticks. And through Metbull, we went out there together, but I've gone out probably another 15 times by myself out there to look. I knew they were there. This is the first one I found. And so I studied this meteorite. I found this one completely by accident. I slipped, I fell, it stuck to my magnet stick. And I was like, wow, I've found a meteorite. I cut it in half. Now I wished I hadn't, because it actually has orientation.
Oh,
Yes.
yes.
So that's
the first one I
absolutely,
found. And like I said, I found it by accident.
This is the one you shared on New Year's Day, right?
No, this I haven't shared this with you
Okay.
guys at all. This is the very first one I ever found. I found this back in October of 23. Found this back in October 23. And once I knew it was a meteorite, I saw the flow lines, I saw the that lip, rollover lip.
Yep.
And I sent it to NEMS, NEMS, and they sent it back as yep, you got a meteorite. You can see the chondrules in it.
Yep.
yep, the metal looks right. The chondrules look right. Yep.
And so I just studied this. Then, of course, books.
Yeah.
That one, the Field Guide to Meteors and Meteorites, is probably the most valuable of all of those for hunting.
Yeah. And I've gone from hunting fossils and rocks. I've got quite an extensive fossil collection to now having a good collection of meteorites, and I love meteorites. It's something that the government doesn't have control over yet. And, as far as fossils are, or mine claims for minerals, something I can go out and look for and just enjoy myself out in the desert looking for them. And I have found 6 out at Jungo. The one that was in the MeteorWRONG part today, I know it's not a dinosaur bone because I've got plenty of dinosaur bones and I collect it. It's not a Pleistocene fossil. It's not a Miocene fossil. It's not bone at all. I was leaning towards hematite only because the red, but it's still pretty cool. And
Yes.
I'm not going to put it in my meteorite collection, but I'll keep it. It's not going in the rock garden.
Yeah,
And
a lot of the people in the
nope.
crew started out with regular terrestrial rocks and then fell in love with those and then moved to meteorites. So for sure, it's a
And
cool rock.
Several of us have a small or large MeteorWRONG collection as well.
Art has an industrial slag collection. So
Yeah,
Yes. Yes.
Awesome. Well, thank you, Adam. I appreciate that. Like, I definitely want like the other viewers and other Rockhounders to, definitely get the idea and understand that doing a little bit of research, doing some reading, viewing some of our educational videos, going to the Met Bowl and looking up, dense collection areas and stream fields, like this is the way to go. If you know people have already found meteorites in this area, you're definitely more likely to find them. And obviously study the terrain, go to the deserts, go to the dry places, don't go to the beach, and start there. So thank you, Adam. Adam had done the streak test, and I believe Pat had provided a link. And we've a link to the Washington University at St. Louis. And Randy Kortev is definitely someone who's a great resource. I know he's retired, but there's a lot out there on the internet that he has shared before. And I know that we have a video where we went through like his, 20 or 30 points. To look for meteorites. So maybe Topher will link that video here. Okay, so this is what we're going to see most of the time. And as it says on the screen, if the rock leaves a streak like this, it's not a meteorite. I know that these tests may or may not be definitive, and they shouldn't be used to prove something is a meteorite. More than likely, it's used as a way of just ruling a rock out. And yeah, note the rusty red powder. This rock is a hematite concretion. And we thought this was interesting. Nearly all barns are painted red with paint that contains hematite because it is so abundant and consequently the cheapest paint pigment. This is something we got from Randy. And then lastly, yes, most of the red rocks in the American Southwest, which obviously that's where Arizona, Nevada, Utah, they're all hematite cemented sandstones. So does anybody else have any parting comments, or are we good to go? Daniel, did you have anything you wanted to add?
So the only thing I noticed about the previous sample from Adam was looking at the inside, it doesn't resemble, putting everything about the outside aside, besides the fact that it doesn't resemble chondritic texture, it also doesn't really resemble a basaltic texture that you would normally see in something like a sugartite or even in like some of the lunar mare samples or eucrites. It sort of looks more like a two-phase rock. One of the phases, of course, given that it's so magnetic, might, be like an iron oxide phase. The other could just be some kind of cemented matrix of some kind. So it doesn't really look too much like a fine-grained igneous rock, at least from what I noticed.
Topher and I were noticing something. Are you like maybe possibly referring to that polished edge of the rock? Like we were looking at that texture and we were both thinking like that doesn't necessarily look meteoritic.
Yeah, exactly.
Okay.
It was the sliced, polished end cut of the inside from the slice. Yeah.
Okay, yeah, exactly. That was our thoughts too. I can't put it into words the way that you do so eloquently, but that really shows the importance, you guys, of filing a matrix. If you have a whole stone and it's not broken anywhere, it really helps us to see the inside. Sometimes we can tell if it's a meteorite or not from the outside, but that definitely helps. So get your filing things out and make us a window. So, all right, guys, thank you so much for joining us, and we will see you next month with some more meteorites and meteorwrongs.
Thanks, Sue.
Thank you.
Bye.
Thank you, Sue.
Good job, guys.